This video will explain how to create a Vitis acceleration embedded platform for Zybo-z7-20 FPGA board. If you are familiar with C++ language and curious about function acceleration on Zinc 7000 and Zinc UltraScale Plus MPSoC using Vitis and do not know where to start, you can refer to my online course. For that purpose, click on the link below this video. The Zybo-z7 is a feature-rich, ready-to-use embedded software and digital circuit development board built around the Xilinx Zinc 7000 family. Here I have selected the Zybo-z7-20, one of the Zybo family, and the goal is using the Xilinx Vitis design flow to accelerate functions on Zybo-z7-20. The first step to achieve this goal is preparing the Vitis platform. So the question is, how can we create a Vitis platform for Zybo-z7-20? Creating a Vitis platform has three main steps. First, hardware. Using Vivado to prepare the underlying hardware components and generate an XSA file. Second, software. Using the Petalinux to configure and generate the corresponding Linux operating system. Third, platform. Using Vitis to integrate the hardware and software components and generate the final platform. Before starting the process of creating a Vitis hardware platform, we should install two software tools. First, Vitis Unified Software Platform, and second, Petalinux. Notice that the version of these two software tools should be the same. Earlier in this course, we saw how to install the Xilinx Vitis 2020.2. We use the same software in this video. To download the Xilinx Petalinux, connect to the Xilinx download page and download the software. For more information or how to install the new version of the Petalinux, please refer to the corresponding UG 1144 document. You can find the document on the Xilinx website. These are the installation requirements taken from this document. Before installing the Petalinux, a group of packages should be installed on your Ubuntu computer. You can find a file containing the list of these packages in the resources folder attached to this lecture. These are the installation steps. 1. Download the Petalinux. 2. Run this command sudo dpkg-reconfigure- 3. Make the Petalinux file executable by running chmod u+x petalinux v2020.2-final-installer.run. 4. Create a folder in your Ubuntu OS. For example, sudo mkdir-p/tools/xilinx/petalinux/2020.2. 5. Note: you cannot install the tool as the root user. While installing the software, ensure that the /tools/xilinx/petalinux/2020.2 Petalinux folder is writable for you. For this purpose, run these two commands. And finally, run the software. ./petalinux-v2020.2-final-installer.run /dir/tools/xilinx/petalinux 2020.2. Please note that you cannot move or copy the installed directory. To check the installation, run this command: source/tools/xilinx/2020.2/settings.sh, and then echo Petalinux. You should see the Petalinux path on your monitor. The first step is creating the underlying hardware components. Create the Zybo-z7-20 folder under the workspace directory. Inside the Zybo-z7-20 directory, create the hardware folder. Then run Vivado. Inside the hardware folder, create a project with the name of Zybo-z7-base-2022-Vivado. In the project type page, make sure that the project is an extensible Vitis platform option is selected. Choose the Zybo-z7-20 as a target FPGA board. Create a block design with the name of Zybo-z7-20-base-2022. Add Zinc IP to the design area. Then run block automation. Double-click on the Zinc IP. Then, in the Customize IP window, under the PSPL configuration, AXI non-secure enablement, GP master AXI interface, unselect the M_AXI_GP0 interface. Also, enable the IRQ_F2P interrupt. And press OK. Ignore the warning messages and proceed. Add a clocking wizard IP to the design area. Double-click on the added IP. In the Customize window, go to the Output Clock tab. Enable clock_out2 and clock_out3 and set them to 200 and 300 MHz respectively. Change the reset type to active low. Connect the clocking wizard IP to the Zinc. Now add 3 processor system reset IPs to the design area. Connect them to the clocking wizard. Then add the concat IP, and after customizing the IP, connect that to the Zinc interrupt port. Now go to the window toolbar and select the platform setup option. Select the AXI ports. Enable the clock_out1, clock_out2, and clock_out3. Change their ID. They must start from 0. Select the clock_out1 as the default clock. Select Add Interrupts. Now we should generate the bit stream. Click on our design in the Sources tab and select Generate Output Products. Then, click on the Design in the Sources tab again and select the Create HDL Wrapper option. After that, click on the Generate Bitstream link. After generating the bitstream successfully, go to File, Export, and select Export Platform. Select the Hardware and Hardware Emulation on the Platform Type page. Then, on the next page, select the Include Bitstream option. Change the name to Zybo_z7-20_base_2022 and click Next. The XSA file will be generated in the Vivado project folder. Now we should prepare the software part of the platform, which is based on the Petalinux. Go to the workspace -Zybo_z7-20 path and generate a folder with the name of software. In the software path, create a folder with the name of Linux_files. And inside the newly created directory, create 2 folders with the names of boot and image. Go back to the software folder. To use Petalinux, first we should make sure the corresponding setting file is executed. So execute the file which is located inside the installed Petalinux folder. Now create the Petalinux project. Go to the project folder and configure that with XSA file generated by Vivado. Misconfig system configuration window will be opened. Keep all the settings unchanged and exit. Now let's configure the Linux kernel. Run the following command: petalinux-config-c kernel. The Linux Xilinx configuration window will appear. Go to the library routines. Then change the size in megabyte to 1024. After that, save and exit the configuration window. Edit the system-user.dtsi file. Add these lines to the file. Then save and exit the editor. Also, modify the user-rootfs config file. And add these lines. Then save and exit the editor. Now we should configure the rootfs. For this purpose, run petalinux-config-c rootfs. The configuration window will appear. Go to User Packages and select all the available packages. Then save and exit. Now we should build the embedded Linux by running this command, petalinux-build. The build process may take a couple of hours, depends on your computer speed. Now we should prepare the SD card and then test the generated embedded Linux. Connect the FPGA board SD card into your system, and using the G-parted software, create a FAT32 partition on the SD card, as explained earlier in this course. Then go to the images/Linux folder inside the Petalinux project folder and copy 3 files to the SD card: boot.bin, boot.scr, and image.ub. Now insert the SD card to your Zybo board and monitor the embedded Linux booting in a serial terminal. Throughout this course, I have explained how you can do this. If you see the login prompt, then your embedded Linux is created correctly. Now we should prepare a couple of files and folders before creating the platform. First, run this command while you are in images/Linux folder: petalinux-build _SDK. After finishing the process, run the created file ./sdk.sh. It asks you to enter a folder path to extract the SDK files. Enter the path of the Linux_files folder that we created earlier in this video. Go to the boot folder created earlier in this video and create a text file with the name of linux.bif. And copy these lines. Then save and exit the editor. Go to the images/Linux folder under the Petalinux project. Copy the u-boot.elf file into the boot folder. Then copy the zinc_fspl.elf file into the boot folder with the name of fspl.elf. Copy the boot.scr, image.ub, and rootfs.cpio into the image folder created earlier in this video. Now go back to the boot folder and create a text file with the name of qemu_args.txt. And add these lines to the file. Now we are ready to do the last step and create the hardware platform in Vitis. Create a folder with the name of platform under the Zybo-z7-20 folder. Run the Vitis software. Choose the platform folder as the workspace. Then click on the Create Platform Project link. Choose the Zybo-z7-20-base_2022 as the platform project name. On the platform page, click on the Browse icon and select the XSA file generated by the Vivado. Choose the Linux as the operating system and press Finish. Then, under the domain window, fill in the empty fields as shown. Now build the project. The created platform is located in the export folder under the platform project. You can take and copy this platform to other places and use that. To test the platform, create a new application project. Choose the created Zybo platform. Please make sure that you do not select the previous version that maybe exists on your system. Choose vector_addition as the project name. On the templates page, select the vector addition template. Compile the project and perform the emulation, as explained throughout this course. Also, you can compile the project for the hardware and boot the FPGA board to test the created platform. If you are familiar with C++ language and curious about function acceleration on Zybo-z7-20 and Zybo UltraScale Plus MPSoC using Vitis and do not know where to start, you can refer to my online course. For that purpose, click on the link below this video.